These are the problems that you asked me to do for you in a video from that review assignment found on pages 253 and 254. And then there will also be a couple of questions at the end dealing with circles, parabolas, hyperbolas, and ellipses that I'll do as well. The two problems that are in orange are questions 22 and 44. Those are what first period asked about, so those are going to be the first ones. And then first period people, if you don't want to watch the rest of the video, you don't have to. And you don't have to wait for those two questions because those are the ones you had. The other ones then will come in numerical order. I did not do all of the problems off of the board because a lot of them are the same thing, and you picked a bunch of questions from the same section in which they all deal with the same stuff. So I picked a couple from each part. Some of them I'm not going to do whatsoever just because they won't be part of the test anyway, and we didn't even go over those parts during the semester. So like the one that I can think of that you really don't have to worry about too much is the one question number 21, which said plot the complex number -5 plus 4i in the complex plane. That's not something you really need to know yet. We'll get to that this next semester. So here we go with these questions, starting with number 22. In question number 22, it asked you to write a polynomial function given the roots are 0, -3, and 1 plus 5i. And remember, anytime you have 1 plus 5i as a root, you should also know that 1 minus the square root of 5i is a root. And so there are 4 of them, and so then your final thing should have x to the 4th as your polynomial function. And since 0 is a root, x is a factor. Since a -3 is a root, x plus 3 is a factor. Since 1 plus the square root of 5i is a root, x minus 1 minus the square root of 5i is a factor. And since 1 minus the square root of 5i is the other one, it's x minus 1 plus the square root of 5i. And they're both minus 1 because you take the opposite of the whole thing, and if you take the opposite of this whole thing, it becomes minus 1 minus the square root of 5i, and then take the opposite of this one, it's minus 1 plus the square root of 5i. Just know that these have to occur in pairs. So then if it said just to write the polynomial function, you could be done with it right there. Now if it says put it in standard form, that's a whole nother story, because you got to multiply all this out, which isn't too bad. You just got to multiply. And we can all do that. At least you should be able to. So you take x times x, and that's x squared. X times a -1 is a negative x, and x times that is a positive square root of 5i x. And then when we do the second one, -1 times all these things. -1 times x is a negative x. -1 times a -1 is a positive 1. And -1 times square root of 5 is a positive square root of 5i. And then if we take this one times all of that, that times x is a negative square root of 5ix. That times that is a negative square root of 5i. And the square root of 5 times the square root of 5 is a negative 5i squared, because you have a negative and a positive, which makes it negative. Square root of 5 times square root of 5 is just 5, and I times I is I squared. And we all know that I squared is a -1, and so a -1 times a -5 is a positive 5. Then combining all of this stuff, you are going to get x squared minus 2x plus 6. Those two go away. Those two go away because they're inverses of each other. And you're left with x squared minus 2x plus 6. And if you, after multiplying these two things together, do not get some quadratic equation, then you have messed up. Okay. Side note, that says 6 if you look at it, because I wrote the 5 really bad. Just seeing if you're paying attention. All right. Then, moving on to this part, if you want to multiply these two together next, you would get x squared plus 3x. And now you have those two things to multiply together. And so you do the same thing. Distribute this to all of that, and you would get x to the fourth minus 2x to the third plus 6x squared. And then when you take 3x times that, you're going to get 3x cubed minus 6x squared plus 18x. Draw our line and add all up that you can. You get x to the fourth plus x to the third plus 18x. And there is your polynomial function. All right, then the next one, which was 44, and so here you're supposed to solve this logarithmic equation, and you cannot solve a logarithmic equation until you get it down to one logarithm. Here we have ln, and so we're going to have to condense this, and because it's subtraction in between when you're condensing, that means division. So you have ln of 2x minus 5 over x equals 1. I suppose we can put that in parentheses. You don't need to if you don't want to. And then now we have to solve this. And when you have ln here, to get rid of ln, you put a base of e on both sides. E and ln are inverses of each other, so they go away. And you have 2x minus 5 over x equals e to the first power. Now we have to solve for x. So the first thing we got to do is get the x out of the denominator. So we want to multiply the entire equation by x on both sides. When you multiply this side by x, this x and that x divide out, and so you're left with just 2x minus 5. This one is just e to the first times x. Now remember, e is just a number. It is 2.718 and change. And so then we have to get the variable on one side. And so we would subtract 2x and subtract 2x. And then you get a negative 5 equals whatever e minus 2 is. And I think it's approximately 0.718 and stuff x. Now remember, you should not round this number here. Here's where you need to use your ANS button. And if you haven't figured out how to use your ANS button at this point in time in this class, then you have been sleeping every day since the beginning of September. All right, so now we have to divide by 0.718 and stuff, which would use ANS. And then we divide by 0.718 also, and so then you get x equals a negative 5 divided by, and then you would use the ANS button, and you would get your answer. And that answer would be somewhere in the vicinity of a value, which I've got to figure. So x is going to equal a negative 6.961 approximately. But now you have to remember something about logarithms. In order for any log with a base or ln, either one of those, the domain for it is all reals greater than 0. So that means this part right here has to be greater than 0. That has to be greater than 0. And if you look at our answer, which is a negative 6.961, that then would not become 0 because it's just x and it's a negative 6, and you can't take ln of a negative 6. You could try, put it in your calculator, and you're going to get an error message. Same thing here. If you put a negative 6 into this, 2 times a negative 6 is a negative 12, minus 5 is a negative 17, so you're still going to get no solution. So this solution doesn't work because of the domain of a logarithmic equation, so therefore there is no solution. And then you're done. All right, now moving on to the rest of the questions, starting with 10 and 11, evaluating a function. This first one says g minus f of 3/4. So you first have to figure out what is g of 3/4 and what is f of 3/4. So substitute 3/4 into the g function. 4 times 3/4 plus 1 is equal to, let's see, 4 times 3/4 is 3, because the 4's divide out, and 3 plus 1 is 4. And then if you do f of 3/4, you are going to get a negative of 3/4 squared plus 3 times 3/4 minus 10. 3/4 squared is 9 over 16, and that's negative. 3/4 times 3 would be plus 9/4 minus 10. Okay, and then you got to add all that up, and then if you need to use your calculator, I suppose you can. But this then would have to change to 16, and if you get that to 16, that becomes 36. And 36 over 16 and a negative 9 over 16 is 27 over 16 minus 10. And if you want to put that as in 10 or 16, that becomes 160. So 27 minus 160 is going to equal a negative 133 over 16. And so now you have f is negative 133 over 16. Oh, yeah. I thought that negative sign, but we took care of that. Okay, so you've got this answer here. Nope. You've got this answer here, and you've got that answer there. And you're supposed to subtract them. So you have to take 4 minus a negative 133 over 16. So that ends up being 4 plus 133 over 16. And you get 197 over 16. Now, doesn't matter what the operation is, the problem is done the same way. If that was a plus sign, then you would add those two things together. If it's a multiplication symbol, then you would multiply the two things that are circled. And if it's division, you divide the two things. This, however, is not a multiplication symbol. It is composition of function. So first, you have to figure out what f of a negative 2 is. This is g composition f of a negative 2. So we take f of negative 2, and our f function is a negative 2 squared plus 3 times 2 minus 10. 2 squared is 4. Negative 4 plus 6 minus 10 is equal to negative 8. Then you need to take that answer and bring it and substitute it into the g function. So g of a negative 8 is what you have to figure out secondly. And so that's 4 times a negative 8 plus 1. Getting your calculator out to do that, that's a 4 times a negative 8, which is a negative 32. Plus 1 is negative 31. Now something is not right with that. Where did I mess up? Oh, hello. I did g composition f of 2, not negative 2. So hey, I don't need to do this over. We're just going to change that to a positive 2. And then you get negative 31. If you use a negative 2, you get a different answer. And I think the answer for a negative 2 is negative 79. Okay. Just understand that G composition F means you do this part first, and then you do that part second with the answer that you got from this first part. And if the F and G are switched, then you do the G part first and then the F part second. Sorry about the little mistake. Hopefully you can make that adjustment. All right, next one. We have to sketch the graph of this fine-looking function and label all the different things that you should be able to label with something like this. And because this is a rational function, it has vertical asymptotes. It has a horizontal asymptote. It has an x-intercept. And it has a y-intercept. And it might even have a slant asymptote. You should know all of these things. So remember, vertical asymptote would be the denominator. What makes that 0? So you have to take x squared plus x minus 6 equals 0. I think we're going to turn that into blue because that's the color we're working in. All right, so now you have to solve that. Are there fractions of negative 6 that get you 1? Yes, there are. They would be x plus 3 and x minus 2 equals 0. And so then x is equal to a negative 3 and a positive 2. So our vertical asymptotes are x equals negative 3 and x equals 2. Find the horizontal asymptotes. Remember, you have to look at the degree of the function. This and that. Since the top degree is smaller, it is that. Doesn't matter if this is 20 and that's 17. As long as the bottom one's the bigger one, it's 0. Doesn't change. Now, if this were 20 and that were 20, when they're the same, then you have to look at the leading coefficient of both things. And in this case, it's 5 over 1. So then you'd have y equals 5 would be your horizontal asymptote. And if it's the other way around, where this one is, say, 2, and this is 1, excuse me, then there isn't 1. And then since they differ by 1, then there would be a slant 1, and to find the slant asymptote, you just divide the numerator by the denominator. And the quotient is your slant asymptote, and that should be a line. You should get like 3x minus 7 or something like that. That only can happen if the top one is bigger by 1. If this is like, say, 7 and this is 4, well, yeah, that's bigger, but it's more than 1 bigger, so when you divide, you're not going to get a line anyway. And so there's no horizontal asymptote. Okay, so those are the asymptotes. Then the x-intercepts would be whatever makes the denominator or the numerator 0. So just take 5x and set it equal to 0, and so x equals 0. That's where it crosses the x-axis. And finally, then the y-intercept. Remember the y-intercept, x equals 0. So then if you put a 0 here, and you put a 0 there, and a 0 there, and that's going to be 0 over a negative 6. Which is 0. So the y-int is also 0, and this is the x-intercept. All right, and then to sketch a graph, if you're going to do that, then remember you would put 5x in your calculator, because you get to use one, divide it, and you have to put the denominator in parentheses. And if the numerator has more than one thing to it, say it had 3x squared plus 5x, you've got to put the whole numerator in parentheses as well. Otherwise, it's not going to look right. All right, moving on. We have to expand this expression, and we kind of did one before where we condensed, and expanding is the inverse of condensing. So here we have ln of x squared minus 4 over x squared plus 1. So we have this, and we have that, and it's division in between, so that means subtraction. So we have x squared minus 4 minus ln of x squared plus 1. And that's all you can do. If there is multiplication, remember that's adding. If this whole thing has an exponent, then you push it out to the front, but this exponent here and that exponent there can't do anything with it because you have a minus 4 that's associated with it as well. So this is considered a whole term. So for example, if you had ln of, let's say, x to the third over y, then you would have ln of x cubed minus ln of y, and then the 3 gets pushed to the front. It's 3 times ln of x minus ln of y. Next one, then you had to condense it. And so condensing, because you have a multiplier in front of a logarithm, that gets pushed to the exponent, so that becomes ln of x squared. Nothing else with these. And so now, condensing, we got to get it always down to one logarithm. And so subtraction in between these two means we divide them. So you have ln of x squared over x minus 1 plus ln of x plus 1. And then addition means you have to multiply this and that. So then you're going to get ln of, and that's like over 1, so multiply the numerator. So you have x squared times x plus 1 over x minus 1. And now you have it down to a single logarithm. The answer would be exactly the same if this were log base 3. The only difference is this would say log base 3. All right, moving on to the next one. I think we have to solve this equation. Yes, we do. It's number 40. Let's see. How about we there we go. All right, so to solve this for x, got to isolate, get the variable by itself. So the first thing we have to do is subtract 21. And then you have 4 to the x minus 5 equals 9. Now then we have to get this out of the exponent. So in order to get that, we've got to get rid of the base of 4. And so we got to log base 4 to both sides. If this were a 7, then you would log base 7 to both sides. If this were a 10, then you just log both sides. And if this were e, then you would ln both sides. And so now log base 4 of 4, those things are inverses of each other, so they go away. And remember, that gets pushed as a multiplier, so x minus 5 equals, and then you have log base 4 of 9. And log base 4 of 9, remember to figure that out. You do ln of 9 over ln of 4, or log 9 over log 4. And then you're going to end up using your ANS button again. And finally, the last thing you have to do is add 5. And when you do that, ln 9 divided by ln 4. That is 1.58. 4962501 if you want to go that far out, but we don't have to write that. Then add 5 to that. And so then you're going to get 6.584,962, and so on and so forth. So you can say x is equal to that, or x is approximately equal 6.585. Okay, then moving on to this one, we have to solve it. Just like the last one, except now this is a little bit funky. And if you look at this, notice anything about both of these two things? Oh yeah, it looks really confusing, I know that. Quit whining and just look at it. They both have a 2 in common, an x in common, and an e to the 2x in common. So let's factor that out. So you have a 2x e to the 2x. And when you divide that out of this, what's left? Well, the 2 goes away. One of the x's goes away, so you still have an x there, and e to the 2x goes away, so you're left with just x. And then if you subtract, and if you take a 2 out there, that goes away, the x goes away, and the e to the x goes away. But now you're dividing, so it doesn't just go away. You have this divided by this, and anytime they're the same thing, that's like 8 divided by 8, or 27 divided by 27, or x divided by x. That is always 1 equals 0. And now you have something multiplied by something equals 0. So we have it factored. So in this case, what does x equal? 1. And in this case, what does x have to be in order to get 0? Well, that has to be a 0 because 2 times 0 is 0, and 0 times e to the 2x is going to be 0 also. Doesn't matter what that one is. That would be 0 as well, and 2 times 0 is 0, and e to the 0 is 1. Just so you remember that. And so those are your two answers. Yes, it looks confusing, but if you just remember your properties and rules and how to solve things in factoring, it's a cakewalk. All right, then page number 45 says you have a perimeter of some rectangular pile. Oh, no, it's a piece of land. And the perimeter is 546. So we have a rectangle. Best thing to do is draw yourself a picture first. Now, all the way around it is 546. And it says that x is the width. You all should be able to at least do that. If you can't do that, then go back and take art again. All right, so now, if this is x, how much is that? That is also x. And so we are supposed to first write the area A of the plot as a function of x. So now we better remember the formula for the area of a rectangle. Area equals length times width, or base times height, however you want to say that. So we know that the width is x. The length now we have to figure out, yeah, how far is it from there to there and from there to there. If we know the whole thing all the way around is 546, we have to take an x for this and an x for that. That's 546 minus 2x. But that would get you this and that distance. So we only need one of them to figure out what the length is. So then we'd have to divide that in half. Now 546 divided by 2 is actually a number, so we can simplify that, and 2 divided by 2 is 1. So then we can have minus x, and half of 546 is 273. And so that is the area. It says use a graphing utility to graph the area function. So then all you do is take your graphing calculator out and put this into your thing, into your calculator, and this is going to be some parabola that goes like that. Now the question says on there, what's the domain? Means what possibilities can you have for x? Here's where you got to use some common sense. because the biggest that the value for the x can be is 273. It can't be 273 because 273 minus 273 is 0, and you can't have a length of 0 or a width of 0 for that matter. So x has to be less than 273, and it has to be bigger than 0. So the domain is from 0 to 273. But it cannot equal either one of those. We can't put less than or equal to because it can't be exactly that. Otherwise, you have no rectangular piece of land. Now, if it was 272, well, then that's like a narrow thing. That would look like this. Of course, much bigger, but you get the idea. All right, then the last part of that says approximate the dimensions of a plot when the area is 15,000 square feet. Well, now take your handy dandy calculator, and this is x. You're going to try to find x, and you know that this is 15,000. So those of you that have a Casio sitting in front of you, you can do a G-solve and go xcal because you're trying to figure out that, and then put in 15,000 for your y value, and it's going to go and give you an answer. Now you're going to have to make sure your viewing window is big enough to see this. So, here's your domain. So the x values should go from 0 to 273. Your y value's going to have to go up to at least 15,000. I would go up to 16,000 just so you can see more of it for your y max, and your y minimum can be at 0 as well. You don't need to go into the negatives because you can't have a negative area. And that's that question. Oh, probably want to know the answer. Oh, that's 45. So let's see. The dimensions would be 76.23 by 196.77. Okay, then the last one, that's it for the, okay, 46. It just asks you to find the different models. Remember, you're just substituting, you put the values into your graphing calculator into the stat part, and then go through and graph it and find the correct buttons to push. All right, then with these last ones, figuring out what you have here and then trying to sketch a graph of it. This first one is 9x squared plus 4y squared minus 18x plus 16y minus 19. Remember, don't know what you're looking at, group the things. You got 9x squared minus 18x, and you've got 4y squared plus 16y equals 119, because you got to move that to the other side. And this would be a plus in between here. And so then in order for you to complete the square, the first thing you have to do is factor out, so you get the x squared and the y squared isolated. So 9 times x squared minus 2x. And this would be plus 4 times y squared plus 4y equals 119. And then to complete the square, you take half of that, so you're going to get 9 times x minus 1 squared. The value, in order for you to be able to write this factor, you have to add 1 to this because it's that squared. Now what you have to add to the other side, because you brought that number in from out here, 9 times 1 is plus 9. And then on this side you have a plus 4 times, and then y plus 2 squared, because you take half of that. And 2 squared is plus 4, but what you add to the other side is 16. So 119, and 9 is 128, and 16 is 144. And then to get it in the proper form, you divide by 144 on both sides. So 144 here, 144 there. And that equals 1. And then you have x minus 1 squared over, and then 9, because you got to get rid of the 9, so you divide that by 9 and divide that by 9. And 144 divided by 9 is 16 plus And this becomes y plus 2 squared, and 144 divided by 4 is 36. And so you are looking at an ellipse. So now the value of a is equal to 6 because it's the bigger number. Square root of that. The value of b is equal to 4, and the value of c is equal to the square root of 50. No. It's a squared minus b squared. So it would be the square root of 20. Our center is located at 1, -2. And since the bigger number is underneath the y, this ellipse is going to be like that. That coordinate is 1, -2. The distance from here to here is 12 because it's 6 there and 6 there. So you got to go up and down 6. So the vertices are 1, -8 and 1, 4. Co-vertices are going to be left and right 4. And so you would have 5, -2 and a -3, -2. Foci are the square root of 20 away from the center, and they would be up and down, so it's 1, -2 plus and minus the square root of 20. That's two things. And then you can draw the ellipse. Moving on to this next one. Well, here we only have one thing that's squared, so that should tell you right there it's a parabola. So in a parabola, remember it's y squared equals 4px, or x squared equals 4py. Well, we have this one, so we want to isolate the y values and move the other stuff to the other side. So you got y squared plus 4y equals -12x plus 28. Now we have to complete the square, and so this is going to become y plus 2 squared because it's half of 4. 2 squared is 4, so we actually had to write a 4 in there, and then that whole thing factors to that. And then since we added 4 here, we have to add 4 here. And so now we have a -12 times x plus 32. Now, since we have this, we have to get it so that it is in that form. So we have y plus 2 squared equals a -12 times x plus minus 32 over 12. And 32 over 12, you can take a 2 out to get 6 and 16. And then you can take another 2 out to get 8/3. And so now the vertex of our parabola, just like the center, is going to be at a positive 8/3, comma, a -2. And the value of p is going to be a -3 because remember this is 4 negative, or it's 4p. And 4 times what is a -12? Well, -3. So p is a -3. So that means at 8/3 -2, and then p is a -3 down here. So you're looking like that. No. Let me change that. Got the vertex correct. And p being a -3 is correct. So you got to go 8/3 -2, but then it's got to be over here. So it's a parabola that's going like this. Sorry about that, because it's y squared, and y squared is not a function. If it were x squared, it'd be the one that I drew first. And then lastly, we have this one here, and same thing, you got a group, and we've got y squareds and x squareds, and because it's a minus x squared, we should put that second. So we have y squared minus 6y minus x squared plus 2x equals 8. Now this one you've got to make sure that the x is by itself, so it's a negative 1 times x squared minus 2x equals 8. And this stays y squared minus 6y. And then you have to complete the square of both parts. So doing this, half of 6 is 3. So y minus 3 squared. And what you have to actually add is 9. And that factors to this. And so then you have to add 9 over here. And on this one, you have a negative 1 times, and this would be x minus 1 squared, because half of a negative 2 is a negative 1. Now a negative 1 squared is plus 1. But then you have to multiply it by this number here, and the negative 1 times 1 is a negative 1. And then if you combine all of that, 9 and 8 is 17, minus 1 is 16. And now, what are we looking at? That's a good question. It could be a hyperbola because you got a subtraction sign in between, but you don't have 1 on that side yet. Oh, so let's make that 1 and we divide by 16. So now what are we looking at? And so then you get y minus 3 squared over 16 minus x minus 1 squared over 16 equals 1. Well, because it's a minus in between the two things, it's a hyperbola. Now, had that been a plus sign there, then you would have to decide if it's an ellipse or a circle. And because those two numbers are the same, it's a circle. All right, so since it is a hyperbola, the value of a is 4. It's that number, square root of it. The value of b is also 4 because it's the square root of that number. And then the value of c is equal to the square root of 32 because it's that squared plus that squared. And then you know that the center of your hyperbola is at 1, 3. And since the value of a, since this is y is first, it's the positive part, we are going to go up 4 and down 4 from that. So you're going to be 1, negative 1, and 1, 7 are your vertices. And then the equations for the asymptotes are going to have slopes of 4 over 4, both plus and minus, so you have plus and minus 1. So then from your center of 1, 3, you go up 1 over 1. It'd be like that, and the same thing here. And then you can make your hyperbola. And that concludes this video. Enjoy the rest of your evening. Hope you do well on the test tomorrow or Friday. If you do have any other questions that I did not cover that maybe you think you still need to have answered, why don't you stop in and see me before school tomorrow? Those of you that take the test right away. Those of you in 4th hour, you have any time tomorrow that you're free. You could come in and see me, or anytime before 4th period. All right? Good night.